Hi, I'm Annie Atkinson, and today I'm here to talk about the Federal Aviation Administration's data on wildlife strikes on aircrafts in the United States. This story is specifically for the attention of the FAA and the federal government of which state is most affected by these strikes. I will be analysing the data and providing suitable recommendations on how they can decrease these rates. First, we'll look at a general overview of the FAA data. As we can see, the data records a total of 28,298 incidents, which is from the year 2000 through to 2015. This has cost the FAA a total of $322,160,887 in total. It was recorded that 25,187 incidents reported no damage to the aircraft, and yet from all the damage caused to the aircraft, it's taken an average 84.76 hours for service time. The most common phase the accident occurs is mostly during the approach and then landing roll, and strikes often occur mostly during the day. Moving on to deciding which state has been the most affected, the map depicts the areas which have recorded airstrikes, with the states recording the highest strikes getting darker in colour, which is clearly New York, Florida, Texas, and California. It's clear that California has recorded the highest total strikes at 3,026 between the years of 2000 and 2015. We can also see which airports have reported the most incidents, with Sacramento International Airport recording 730 wildlife strikes, followed by Los Angeles International with 395, and then San Francisco International Airport with 317. Next, we'll be looking at the factors that could be influencing the strikes in California. We can see that birds have been the cause of 2,902 accidents, substantially more than bats and terrestrial mammals. We can see that the top 10 species involved in the airstrikes, having gulls at number 1, causing 232 incidents, then rock pigeons close behind with 230 incidents, and then red-tailed hawks with 186 incidents. We can also assume that the phase of flight may impact the incidents, with 1,234 incidents occurring in the approach phase, followed by landing roll phase and the takeoff run phase. The time of day may influence the data as well, with 2,069 incidents occurring during the day. Now we'll look at the damage and cost for California. The amount of damage it has caused to aircraft is most often none, with 2,625 reports, with the occasional minor and substantial damage. There was more likely no indicated damage in comparison to caused indicated damage, and there was almost always no impact to the flights either, with 2,678 reportings, yet there was the occasional precautionary landing. It's reported to have damaged 5,783 engines, averaging 23,063 hours the aircraft was out for servicing, which is around 2.5 years. The total cost of these aviation incidents for California was $29,671,432. Furthermore, I've developed some recommendations for the FAA and the California federal government to help improve these statistics in California. My first suggestion is for the FAA to collaborate with wildlife conservation organizations, sharing data and research. This way they can gain expertise in bird migration and behavior patterns and local habitats to identify high-risk areas and times to avoid, with hopes of decreasing these strikes. My next suggestion is to implement an enhanced pilot training and awareness program that will provide pilots across the US with comprehensive training program on techniques to avoid these wildlife strikes, to ensure pilots are well educated and responding to a strike situation. My final suggestion would be for the Californian federal government to discuss with other states their tactics on keeping the incident rates low. As we can see, Wyoming, Delaware, Vermont, Nevada, and Montana all record under 100 incidents from the year 2000 to 2015. They may have tactics, trainings, or preventative measures in place that prevent wildlife strikes. Now I'm going to discuss my visualization techniques. Across all my dashboards, I tried to keep a theme of using variations of reds and oranges to color my graphs and visualizations. It is said that red is recognized by the brain faster, and in front of the off-white shading I've chosen for the background, it attracts attention and stands out. I wanted to keep my visualization simple and easy to read for the audience. Therefore, I've chosen my first 3 forms of data in their total numerical form for a clear understanding. The phase of flight is a ranking graph, so it's better understood by viewers when placed in a descending order, And the bottom tree graph displays the data from left to right, descending order of their size, which the visual hierarchy says is an effective display of data. Moving on to the next slide, if we look down to the largest element of this slide, the map, I've chosen to represent the total data in this way so we can identify quickly which states are reporting the highest incidence. The red color choice helps the outliers stand out. Again, I've placed California's total strikes in its numerical form for quick reading. Moving to the tree map at the top, the data is hierarchical, as we can see which airports are most affected. So it was a suitable use to display the data and is easy to read from left to right descending. Next, I've created a horizontal bar chart to display the top 10 species involved in strikes. This was chosen as the names of the species are quite long, so a column chart would look messy with longer names. I've decided to display the animal categories in a packed bubble to display the extreme rate at which birds are causing the strikes rather than the other species. The bottom two graphs are both descending column charts. We can see the proportions of the categories clearly and understand the data. Here we can see both amount of damage and impact to flight are displayed in horizontal bar charts, as the labels are easier to display. It can also be said to be viewed more naturally, as column charts would require rotating the text. I've included the total cost of California, average time aircraft is out for servicing, and number of engines in total numerical form, as already mentioned, is because of easier understanding. The indicated damage is featured in a pie chart as there are only two categories, so you can easily compare category sizes. Finally, to the recommendations, both the top 10 species involved in strikes and the airports in California with the highest strikes are both shown in horizontal bar charts, again due to their large category names. The states with the lowest strikes are shown in a simple table using the darkening colors to represent the increasing number.